All right, the law of sines. To understand the law of sines, first you need to understand this general triangle. This triangle has sides A, B, and C, and the angle measure across from each side is angle A, angle B, and angle C. So it doesn't matter how your triangle is oriented, as long as your side and your angle match up. The angle and the side that's across from the angle. Alright, so if we have this general triangle, then these three fractions or these three proportions are equal. The sine of angle A over side A is equal to the sine of angle B over side B is equal to the sine of angle C over side C. Now, to set up an equation and solve for an angle or a side, I need to have two of these proportions. So I'm either going to have this proportion equals this proportion, the first proportion equals the last proportion, or the middle proportion equals the last proportion. Now, to set up a law of sines problem, there is one thing that you need to make sure that you have, and that is an angle measure and the corresponding side. You must know at least one angle measure and its corresponding side. Okay, so if you don't know an angle measure and the side across from it, you can't use the law of sines. Alright, now, just like with any equation, when you set the equation up, or when we set these equations up, we're going to know everything except for one variable. Alright, you only want one variable that is unknown in any equation if you go to solve an equation. So, not only do we need to know an angle measure and its corresponding side, but when I set up an equation to solve for something that I don't know, I can only have one value that's unknown. Okay, there are several different types of triangles, and they're classified by what you know about the triangle. One type of triangle is called a side angle angle triangle, and it's called a side angle angle triangle because you know the length of one of the sides, and then in a counterclockwise rotation or in a clockwise rotation, you know two angles in a row. So, for example, let's say that I had this triangle. Let's say this side here was 5, and then this angle up here, let's say, is 50 degrees. This angle right here, let's say, is 40 degrees. And then I don't know this side down here, so I have to make it a variable. I'm just going to make it a lowercase b. I don't know this side over here, so I'm going to make it lowercase a. And then I'm not given this angle measure right here. So this is a side angle angle triangle. Alright, to solve for a side angle angle triangle using the law of sides, the law of sines, what we need is an angle measure and its corresponding side. We have to know an angle measure and its corresponding side, which is the side across from it. So notice that I know this angle measure is 40 degrees, and I know that this side is 5. Those are corresponding. Those go together. They're related. Alright? So I can set up the proportion, the sine of 40 degrees over 5. Alright, so this is the first part of my equation. I'm going to use this proportion to help me solve for side A and for side B. Now I can't solve for both of them at the same time, so I have to take them one at a time. So let's look at what we don't know. We don't know A. We weren't given angle A, but I'm thinking we could figure out angle A because the three angles of a triangle have to add up to be 180 degrees. So how can I figure out angle A? I can say angle A equals 180 degrees minus 50 degrees minus 40 degrees. So angle A is going to be 90 degrees. Now, even though it doesn't look like it's 90 degrees, that's okay, because triangles don't always scale, especially on these problems. The way they look is not always going to be what it's supposed to be. So, make sure you work out the problem and you don't just guess what an angle measure should be. Alright, so now we know angle A. That was one thing we didn't know. Now, if I want to solve for side A, then I have to use this proportion that I know works for sure, which was the angle measure and the corresponding side, something that was given in the problem. And I say this equals. Now, if I want to solve for side A, I need to also use the proportion of side A and the angle across from it. And now I know what angle A is. I can set that proportion up. We said angle A was 90 degrees. So this is equal to the sine of 90 degrees over side A. Alright, so I set two of the fractions or proportions up. I have to use this sine of 40 degrees over 5 to solve for the other sides that I don't know. And then I set up this other proportion, this one here, to help me solve for side A. Now, I have one variable. That's what we must have. We can't have more than one variable whenever we're working one of these out with the law of sines. So, to solve for A, I would cross multiply. So you're going to say A times the sine of 40 degrees equals 5 times the sine of 90 degrees. Alright, and to get A by itself, I divide both sides by the sine of 40 degrees. Alright, and so now I'm going to have to use a calculator to work this out. Make sure your calculator is in degrees. Alright, so side A is approximately, 5 times 90 sine equals divided by 40 sine equals. I'm going to round my sides to two places always. Just make sure you look at the directions and see what it says. This would be 7.78. So it's approximately 7.78 units. Alright, so we've solved for side A. The only thing that we have left to solve for is side B. Now when you set up the next proportion or equation to help you solve for side B, make sure that you use that same fraction or proportion that we used to help us solve for side A. We don't want to use side A unless we just have to, because we rounded side A. So whenever you solve for side B, make sure you use that proportion that we started with. So my next equation is going to be the sine of 40 degrees over 5 equals, now if I want to solve for side B, I have to use side B and the angle across from it, which is 50 degrees. So sine of 40 degrees over 5 equals sine of 50 degrees over B. Alright, so to solve for side B, cross multiply. So you have B times the sine of 40 degrees equals 5 times the sine of 50 degrees. And then to get B by itself, you divide both sides by the sine of 40 degrees. Alright, so now I can approximate for B. So B is equal to 5 times the sine of 50 divided by the sine of 40. Alright, so side B is approximately 5.96. So now I've solved for all of my sides and all of my angles. All right, so that was a side angle angle triangle. As long as you have side angle angle triangles, pretty much will always work out like that. Another pretty easy type of triangle is an angle side angle triangle. It's called angle side angle triangle because you know in either a clockwise or counterclockwise rotation, you know an angle, a side, and another angle, all in a row. All right, so for example, let's say that this angle measure was 35 degrees. This angle measure was 25 degrees. And I don't know this angle measure, so I'm going to call it angle C. Let's say that I know side C is 5. I don't know side B, and I don't know side A. Again, it doesn't matter where your angles or where your sides are as long as they correspond, meaning angle A is always across from side A, angle B is always across from side B, and angle C is always across from side C. So now, when we first look at this angle side angle triangle, what we want to find is a corresponding side and angle. If we don't have that, we can't use the law of sines. At first look, you may say, well, you don't know a corresponding side and angle. But since I know two of the angles of this triangle, I can solve for the one that I don't know. So I can say 180 degrees minus 35 degrees minus 25 degrees. So that's equal to 120 degrees. Again, don't look at this thing and think, oh, well, that can't be 120 degrees because it doesn't look like it's 120 degrees. Just, you know, as long as you do the math correctly, you should get the right answers regardless of what the triangle looks like. Okay, so we figured out that angle C was 120 degrees. Now we know a side and a corresponding angle. So the proportion or fraction that I'm going to use to help me solve for my sides that I don't know is the sine of 120 degrees over 5. Right, I'm going to use that to help me solve for side A and side B. Let's solve for side A first. So to solve for side A, I have this proportion set up that I'm going to use to help me solve for everything. And for side A, its corresponding angle is 35 degrees. So I say equals the sine of 35 degrees over A. Now I cross multiply and divide. So A times the sine of 120 degrees equals 5 times the sine of 35 degrees. So get side A by itself by dividing both sides of the equation by the sine of 120 degrees. Now in your calculator you can get an approximation for A. So that is 5 times the sine of 35 degrees divided by the sine of 120 degrees. And don't forget to hit equals after you work out the top and then after you divide by the bottom.
Do you get sine after you put in 120?
Yes. Alright, so side A is approximately 3.31 if I round to two places. Alright, now to solve for side B, remember I said don't use side A unless you just have to. Okay? And if we did have to go back and use side A for any reason at all, I'd want to carry it out more than two places. Okay, so let's just use the proportion that we were given that we know for sure, sine of 120 degrees over 5. Alright, so the sine of 120 degrees over 5 is equal to, now the only thing we don't know is side B. So we want to set up the proportion with side B and its corresponding angle. So that's sine of 25 degrees over B. Now cross multiply. So I have B times the sine of 120 degrees is equal to 5 times the sine of 25 degrees. So divide both sides by the sine of 120 degrees. So side B is approximately, Let's work this out in the calculator and see. 5 times 25 sine equals, divided by 120 sine equals. Alright, so I have 0.49. Usually when I get something that small, I double check. So I'm going to double check my work or my answer real quick. 5 times 25 sine equals, divided by 120 sine equals. So I must have punched something in incorrectly. So since I have a different answer when I punched it back in, how about I do it a third time just to check. So 5 times sine of 25, so 5 times 25 sine equals, divided by 120 sine equals. Alright, so I got the same thing twice in a row, so that must be it. 2.44.
I thought you were to put the sine 120 in front.
Alright, so if we have a side-side angle triangle, not an angle side-side, but a side-side angle triangle, then that means we know two of the sides in a row, and we know an angle measure. Now what that's going to cause us to do is check and see, do we have one triangle or do we have two triangles that would give us answers with the provided information. For example, let's say that I was given a triangle and I was told side A equals 3, side B equals 2, and angle A equals 40 degrees. Again, it doesn't matter how you label your triangle, just make sure that angles and sides correspond correctly. So let's say that I make this 40 degrees, then because that's angle A, side A needs to be across from it, this is 3. Then if I make side B, if I make this 2, then this is angle B. The only thing I have left is side C and angle C. Now, I do have a matching angle measure and side. So that's the first thing that I want to write down. I want to write down the proportion sine of 40 degrees over 3. Now let's look at what we have been given. We were given this side and we have a corresponding angle that we don't know. So I can set up a proportion. The sine of angle what? B over 2. Now notice that I only have one variable in my formula or in my equation, and that's what I want, just one variable. So get the sine of B by itself. So cross multiply, you'll have 2 times the sine of 40 degrees equals 3 times the sine of B, and now get sine of B by itself. Divide both sides by 3. Alright, so I have the sine of B is equal to 2 times the sine of 40 degrees over 3. So what I want to do, I'm trying to actually figure out the angle measure. So you want to work out the left side here. You want to say 2 times 40 sine equals, divided by 3 equals. Now this decimal is all of this over here. Now to figure out the angle measure, I have to use the inverse function. So you say inverse sine. So this is the angle measure that would correspond to. Alright, so I'm going to round this angle measure to one place. So this is about 25.4. Alright. Once we solve for this angle measure, this is where I can tell is there going to be one triangle or two triangles. The way that you do that is you take this angle and say this is B sub 1. This is going to be an angle measure of my first triangle. The way that I can tell is there an actual B sub 2. b sub 2 would be equal to 180 degrees minus b sub 1. So 180 degrees minus 25.4 degrees. If there is another triangle, this is what b is equal to in my other triangle. So that gives me 154.6 degrees. This would be b in my second triangle. Now, the way that you tell, is there a second triangle? You take this angle measure and add it to the given angle measure. You see the given angle measure in the triangle? It was 40 degrees. Could this be a triangle if I took what my angle from my second angle measure for B, or the angle measure for B in the second triangle has to be, and I add the given angle measure? Does that leave any room for a third angle? No, because I get 194.6 degrees. And a triangle can't have that many degrees, or it can't have that degree measure if you add up all three angles. Alright, so let me go back through real quick. What did I do? I set it up just like normal, and I solve for one of the angle measures that I don't know by using the calculator and the inverse function. Then, once I've found an angle measure, I say the other possible angle measure for a second triangle will be 180 degrees minus what I found for B. So that's my B in my second possible triangle. Once you know what that is, add the given angle measure back to it, and if that's less than 180 degrees, that leaves some room for that third angle. If it's greater than or equal to 180 degrees, that doesn't leave any room or any angle measure for angle C, which this one was bigger than 180 degrees, so it didn't leave any room for a third angle measure. So this means that there is no second triangle, because this was greater than 180 degrees. So I don't have to do anything on this problem with another triangle. Now that I know there is not another triangle, I can solve for angle C. How can I do that? Well, you were given that one angle was 40 degrees. You figured out that another angle is 25.4 degrees. So to figure out the third angle of the triangle, you say that has to be equal to 180 degrees minus 40 degrees minus 25.4 degrees. So punch that in your calculator, and when you do, you'll get that angle C is 114.6 degrees. Now, the only thing left to solve for in the triangle is side C. You know everything else. So the way that I want to solve for side C, I want to start my equation off just like I did when I solved for angle A. Use that same proportion. So when I started off, and I solved for angle B, I used 40 degrees over 3. So I want to say the sine of 40 degrees over 3 is equal to, now I want to solve for side C, and I just figured out angle C. So it's equal to the sine of 114.6 degrees over side C. Now notice I only have one variable in my equation. That's the way we always want to set our equations up, so that we only have one variable. Now get C by itself, or you can cross multiply and divide. And side C is approximately, we're going to use our calculator. We don't have to use the inverse function on this one because we're not solving for an angle measure. We'll only use the inverse on the calculator if we have to solve for an angle measure. So I say 3 times 114.6 sine equals divided by 40 sine equals. So side C is about 4.24. And we've solved for all of the angles and all of the sides of that triangle. Let's take a look at another side-side angle triangle. Let's say that we were given side A equals 6, side B equals 8, and angle A equals 35 degrees. So even if I don't know that this is a side-side angle triangle before I start, you're given two sides and you're given an angle. Alright, so say if this side is 6, this side is 8, then this would be the angle 35 degrees. Notice that side A and angle A are corresponding in my triangle. The rest of my stuff I'm just going to make variables up for. Since it said that side B was 8, I was given that, I'm going to make this angle B, and then the only thing left is to make an angle C and a side C. So this is a side-side angle triangle. So either I'm going to have one triangle, I'm going to have two triangles, or I'm going to have no triangles. Okay? So let's see. So first you need to identify the angle measure and the side that correspond. So the sine of 35 degrees over 6 is equal to, now I can solve for angle B because I know that side B is 8. So that equals the sine of angle B over 8. Now since I have sine of B, I'm going to have to use the inverse in my calculator. So cross multiply and you get 8 times the sine of 35 degrees equals, cross multiply again, 6 times sine of B. Now get sine of B by itself by dividing both sides by 6. Here's where I'm going to use the calculator. Make sure your calculator's in degree mode. Alright, and so work out the left side. I'm going to say 8 times 35 sine equals divided by 6 equals. Alright, and so this is what the left side of this equation is equal to. Now say inverse sine. So this angle measure, angle B, is 49.89 degrees, but if I just rounded that to one place, that would be 49.9 degrees. Alright, so angle B is about 49.9 degrees. Now this is the place where with a side-side angle triangle, or this is the time that I'm going to check and see, is there another triangle? We know that one triangle is here for sure. Let's see if there's a second one that would work out with this given information, or with the given information. The way I can tell that is I'm going to make this value here B sub 1, so this is B from the first triangle. If I have another triangle, B for the second triangle is going to have to be 180 degrees minus 49.9 degrees. Alright, so 180 minus 49.9 gives us 130.1 degrees. Now, if I do have a second triangle, this is what angle B in the second triangle is equal to. The way that I can tell is there a second triangle, I take the value for angle B in the second triangle and I add the given angle measure to it. If that's less than 180 degrees, then that leaves an angle for C. If it's greater than or equal to 180 degrees, there won't be a second triangle. But you see, when I add those two together, I get 165.1 degrees. So what that means is there are some degrees there left so that I can have an angle C in a second triangle. Alright? So I can either keep working with the second triangle, or I can go back and finish the first triangle, and that's what I'm going to do. But keep in mind, with the second triangle, we're going to have all these same values that I wrote down at the very beginning, and then angle B in the second triangle is going to be 130.1 degrees. Alright? So let's not use the second triangle yet. Let's finish working out the first triangle. So in the first triangle, I know that angle A is 35 degrees, angle B is 49.9 degrees. Then to solve for angle C, and I'm going to call it C sub 1 so I don't forget, this is for the first triangle. That's going to be 180 degrees minus 35 degrees minus 49.9 degrees. This is going to give me what angle C is equal to in my first triangle. So that's going to be about 95.1 degrees if you punch that in your calculator. Alright, so now the only thing that I don't know is side C. So let's use the proportion that we used at the very beginning, the angle and side that we know correspond. That's the sine of 35 degrees over 6. Alright, that's equal to, now if I want to solve for side C, I've got to know angle C, which I do, and I've got to set up a proportion for that. So that's equal to the sine of, we said angle C in the first triangle is 95.1 degrees divided by side C. So notice in my equation here I only have one variable. Now to solve for that variable, cross multiply. So you get C times the sine of 35 degrees is equal to 6 times the sine of 95.1 degrees. Now divide both sides by the sine of 35 degrees. Alright. So it's going to be 6 times 95.1 sine divided by 35 sine equals. Alright, and I get 10.42. So now I've solved for triangle 1. So that's all my values for the first triangle. So now I need to find the values for the second triangle. Now all the given information up here that I wrote down, or that was given to me in the triangle that I wrote down, all this is the same. What's going to be different is now in the second triangle, B is equal to 130.1 degrees. So C in the second triangle is going to be equal to 180 degrees minus the given angle measure, which was 35 degrees, minus 130.1 degrees. So the angle C in the second triangle is 180 degrees minus the given angle measure minus the new, or the second, angle B. Alright, when I do that, I'm going to get my second angle C equal to 14.9 degrees. Alright, so I have this triangle where I know angle B now for my second triangle. I know angle C for my second triangle. The only thing I don't know is side C. To solve for side C, I need to use the proportion that I used at the very beginning, which was the sine of 35 degrees over 6. Alright, and so that equals, now I'm trying to solve for side C in the second triangle. So that equals the sine of angle C in the second triangle, 14.9 degrees, divided by C. That's side C. So cross multiply and divide. And let's see what we get. So 6 times the sine of 14.9 divided by the sine of 35 equals, alright, and I got that the second side C, if I round the two places, is 2.69. So see, side C is about 2.69. 9. Alright, so I've solved for all of the sides in the second triangle. So you may be wondering, I told you, I said with the ambiguous case, with a side-side angle triangle, either you're going to have one triangle, two triangles, or maybe no triangle at all. Okay? I'm now going to show you how your calculator can tell you if you have no triangle at all. So, let's say that I have side A equals 2 units, side C equals 1 unit, and angle C equals 55 degrees. Alright, so set up a triangle. We have one corresponding side and angle. So if I make this 55 degrees, then this is side C. So if I make this A, then this is angle A that makes this B and side B. So it's angle B and side B. Now, I start this problem out just like I would any other problem. And I say, okay, I know this angle measure and this side. So sine of 55 degrees over 1 equals, now what would I do next? I'd solve for an angle. I have this side corresponds to this angle. So set up the proportion sine of angle A over 2. So now to solve for angle A, I do the same thing that I've done on the previous problems. Cross multiply. So I have 2 times the sine of 55 degrees is equal to 1 times the sine of A. So multiplying by 1 does nothing. So now I use the calculator, and since I'm solving for an angle measure, I have to use the inverse. Right? So 2 times sine of 55, so 2 times sine, 2 times 55 sine equals, so I've worked out the left side. Now see what happens when you push inverse. Inverse sine. This calculator says invalid input. You should see what your calculator tells you. The reason why it says invalid input is because I just tried to take the inverse of something that's bigger than 1, and you can't do that for sine. Okay? So that means there are no triangles. There's no triangle. Alright, so set up your proportion, cross multiply, solve for angle A, then use the inverse, and you should get an error with your calculator. That means there's no triangle.